Assalamu alaikum. So yeah, this is the video for our DAA project. It's on minimum spanning trees. It uses the algorithms, prims, and kruskals. And the extra thing about the special part about our project is that it uses a random graph generator, and the algorithms are implemented on these graphs. And this is our group. So yeah, let's get on with it. So yeah, the code starts with a graph. It's a simple class. This is the adjacency list. This is the adjacency matrix. This is the list that keeps all the arrays, and this is the boolean which decides whether a graph is directed or undirected. Okay, so there is a data type edge here, and there's a data type vertex here. So edge has a source and a destination, and it's basically one-way traffic. Okay. That's why it has a source and direction. It's monodirectional, and then there's a weight, and then there's a vertex. They have a value and a weight. There is nothing new about it. So yeah, so yeah, the so how the constructor works is you input a list of edges into this graph, and then this graph automatically generates the vertices and and automatically creates the adjacency list for the graph. Okay, and that's how the graph gets made. The adjacency matrix is not made here. Okay, so yeah, so the special part about our project is that it uses a random graph generator. So I'm going to generate some random graphs. This is the adjacency list. I hope you can pause the video and make the graph yourself. They're gonna be accurate. Okay, so yeah, I'm gonna generate some more. In fact, let's make this 10, and even if I make this 10,000, which is a bit overkill. Yep, no errors. So it's good and it works. And let's make this 16 and make this 5. It's still gonna work. That's gonna take some time though. Yep. So it's done. So yeah, this is the adjacency matrix, and this is the adjacency list. So anyways, let's make this a bit normal and move on. Okay, so how does the random graph generator work? So first you enter the minimum number of vertices you want, and then you enter deviation. Okay, deviation is something like how deep should the edges go, and it plays a role in deciding how many edges should a node have. Okay, and then there is int weight. This w means the maximum number of weight you want your edges to have, and boolean directed simply means if you want your graph to be directed or undirected. All right, so we create a list for edges, and then we create a test array list. Basically this list, it helps out with the randomization process. Okay, so we generate a new random number, or a new random number generator, and then we generate a random weight, and then we connect like the next, like I and I plus one node together. Okay, so yeah, the base case is k 1 2 से connect होना चाहिए, 2 3 से, 3 to 4, 4 to 5, 5 to 6. Okay, like this is, like we want the base case, so that there it just promotes the stability of the graph. Okay, otherwise the weights are already randomly generated, and there is no, like, fishy business. Okay, so and then we generate another random number, random integer, which decides how many maximum edges should a node have. Okay, so j is equals to 1 simply means that a node already has its base case fulfilled, and max number, and then we run a while loop basically decides which basically then assigns the edges to the nodes by also randomly generating them. We generate a new weight, and then we pick a random integer from the test array list. Then we create this edge. Okay, we add j to it. we add j because we want some depth and some variation, and then we remove that integer, and then we max v is basically I want to know what's the max, the furthest or the deepest vertex of the graph, okay? And j plus plus simply means k one edge has been made, so move on with the loop. And there is also another max v. It's because just in case this thing becomes zero, this thing's not gonna run. So what you're gonna get is I as max v if this line is commented out, okay? But you want I plus 1 here. So that's the purpose of this line. And then simply you insert this list of edges into the graph. You create the adjacency matrix. Adjacency matrix is simply कि source और destination उठा ली, उसको index बना लिया और उस पे weight डाल दिया. And then this is for directed and undirected graph. So yeah, I've generated some graphs for you. So let's get on with prims. So prims is an algorithm that uses an adjacency matrix. It is used for directed graphs and it finds a minimum spanning tree. So yeah, so in the code you'll find that there are two prims. This is the double M1 and this is the single M1. We're using the same single M1. The double M1 was like my own implementation. Like I wanted to do prints myself based on my understanding, but there were some cases that I missed out, and the case is same with Crucible. Okay, I missed out several cases, so it's just for showing the effort. Okay, so prims is simply you finding the minimum edge inside the adjacency matrix. There is no rocket science about that. And what this code does is after finding the minimum edge of a node, it then it also has a boolean array uh which just says okay, yeah, we're done with this vertex, move on. Okay, so yeah, you get printed out uh what number of edge it is, uh source, destination, cost, uh then it becomes true, and then you add it to the sum. You add it to the sum so that you can get the total cost. Okay, total cost, and that cost is here. So yeah, if I run this algorithm across 10 randomly generated graphs, it's gonna give me some random cost. And you can pause the video and check for its accuracy. The graphs are already small, like they are like 7 vertices, maximum 8 vertices each. So yeah, you can pause the video and check for the accuracy. Okay, so next we're gonna do is move on with the Crucible. So Crucible works with undirected graphs. So yeah, we want the directed boolean to be false. We run this one. Yeah, so yeah, it just takes in the adjacency matrix, and as we set this to false, what it's gonna do is run this code, this one, or this is simply okay, you make the edge bidirectional. Okay, so yeah, let's generate some graphs. See what I meant by bidirectional. 6 6 6 6, mirror, symmetry, mirror. You start mirroring it across this line. Okay, y equals to negative x. So yeah, we're getting some cost, and this is like the route which your algorithm is gonna take. So what Kruskal is doing over here is it creates an array of parent vertices, and then it simply starts sorting the edges, and after sorting the edges, it starts to pick out minimum the minimum weighted edges, and then it simply adds those minimum weight, add edges to the minimum cost, and voila, you get the minimum cost of your spanning tree. So yeah, that's the most of the part is done. So yeah, let's have a little bit of fun with both of them. So I'm gonna set this to true because first we're gonna run prim, and prims is for directed graphs, okay? And then let's also print this again to show, okay, morph UD means to simply morph a directed graph into an undirected graph, the adjacency matrix, okay? So basically, what I'm gonna do. I'm gonna basically swap the indexes and copy the weight, okay? So yeah, let's run this. I think I should print the adjacency matrix two times, one for the directed and one for the undirected. So yeah, first the graph is directed and then it becomes undirected, and this is prims, the route it's gonna take, and then this is what we call it Kruskal's, and the route it's gonna take, okay? So yeah, this is pretty much how what our project is, and the reason we chose a random graph generator is that so that okay, we don't make some makeshift case where both the algorithms work in, like, basically how certain students do it. So yeah, now what I'm gonna do is let's make a small graph and demonstrate it, okay? Let's make this one and let's generate it some several times. And let's not print the adjacency matrices. Okay, I'm gonna generate it several times. Okay, so this is what I'm gonna, like, I'm gonna make a short graph. I'm gonna show you how the calculations are done. Okay, let's just find a graph which has different cost. And yeah, Kruskal's and Prims have different cost. Okay, there was an article on internet which said कि दोनों की cost same होती है regardless the graph is directed or undirected, and it wasted a lot of my time, and the guy was wrong. He did not know what he was talking about. So the problem over here seems to be that there is no problem. It's simply okay, the graphs are too small. Oh yeah, we found a case. Okay, so yeah, you see, I told you. Okay, the cost can be different. We the graphs are too small right now, so most of the time the cost is gonna be the same. But if you pick a bigger graph, see instant difference. You're gonna see difference all across. So yeah, let's make this graph short and find. Okay, yeah, this one's gonna do. Okay, so I'm gonna make this graph and do a small demonstration. Okay, so this is how the directed graph looks like, and this is the exact same undirected graph. Okay, so yeah, let's just map it out. So first it goes from 1 to 2 and then to 2 to 4. So 1 to 2 and then 2 to 4. We're gonna turn this green, okay, because that's the route it's taking. And then we're gonna say, okay, 4 to 5, 5 to 6, 1 to 3, 4 to 5, 5 to 6, and then 1 to 3. Okay, so yeah, 1, 2, 3, 4, 5, 6, and 12. Okay, so let's hope the cost reflects. Yeah, it does. Okay, now let's move on to the undirected graph. Okay, the green part is the starting vertex. Okay, so yep, 1, 2, and 5, 6. 1 to 2, and then 5 to 6. It's picking the most, it's picking the smallest of the edges with the smallest weight first. 2 to 4, 4 to 5, 2 to 4, and then 4 to, wait, 2 to 4, and then 4 to 5. Oh yeah, 4 to 5, yeah. 4 to 5. And there is one last edge, 3 to 4. And that is also green. So 1, 2, 3, 4, 5, 6, 12. Oh, 11. 11. So yeah. So yeah, you can, we're, we're gonna ship our code with the project, with the video link. So yeah, you can check it out for your own, for your own, just for your own satisfaction. And this was our project. This is us, and this is the special thing about our project. I hope you like it, and Allah Hafiz.